Unit 3, Lesson 1. Give you the short story. Zeros, roots, and x-intercepts are the same thing. Say that again. Zeros, roots, x-intercept are the same thing. Okay? They're finding the same thing. Zeros of a function is an x-intercept. A root of the function is a zero. These three terms mean the same exact thing for quadratics. Okay? So we're just going to go through that. You're going to kind of overstate it, so you're probably going to get bored with it a little bit. But zeros, roots, and x-intercepts are the same thing. Okay? So function and function notation review. So a function relation or a function is a special type of relation in which each element of the domain is related to exactly one element of the range. So for every x, you have one y. That's the rules for functions. Okay? Function notation is writing stuff in f of x form. Okay? So that just means, for example, if I say f of x is 4x minus 8, that's function notation. It's saying the function of x is 4x minus 8. And so the different ways you can plug this in, this stuff is review, so that's why I'm just kind of skimming through it, is f of x is 4x minus 8. So what is f of 5? That means we put 5 in for x. So f of 5 is 12. So the point 512 is on that function. Okay? That's all this stuff's talking about, is just how to use function notation. Okay? If you need more review of function notation, feel free to ask me, but simply it's writing function of x. F of x is simply just y. If you're wondering what is that, that's where the y is usually, right? So the f of x is just in the y spot. You're saying function of x because it's a function of x's. Okay? So like for the example here, they're showing you is for this line, 4x minus 8 is a line, right? Slope before. We can say the 0 of the function f of x is 2. Because when I plug 2 in, I get 0. All right. So 0 of the function is 0 of the function of the value of the independent variable, which makes the value of the function equal to 0. Zeros of a function can be found by solving the equation f of x equals 0. So you're making y equals 0 and solving. So essentially what you're doing here is you're taking this, you're making it 0, and you're solving for x. These are linear. Okay, these are linear. We're going to be doing squares and quadratics, though. Okay, they're just setting you up. Yeah, so this one's x is 3. So you're going to add 21. 21 equals 7x. Divide 7. Divide 7. X equals 3. Okay, so if you're lost, all they're doing is we want to know the 0 of the function. So we set the function equal to 0. So this f of x, we just change that to 0 and solve the function. Okay? All right. What Parker just said is, so then at the end, I mean, this is fine. This works. But you also could say this if you're using function notation. F of 3 is 0. Because when you put 3 in for x, that's when you get the 0, right? All is fine. Okay. Investigation 1. So connecting them. So we're going to go through here. The graph of 2x minus 6 is shown. So that line there is 2x minus 6. Determine the x-intercept of the graph algebraically and graphically. So if I want to find the x-intercept is when y is what? 0. I mean, they're gonna kind of, like I said, they're gonna overstate this. You're gonna get bored with it. So you do this, right? Add the 6, divide the 2. X is 3. They said also graphically. Well, how could we see it graphically? Oh, 1, 2. Oh, it's x is 3, right? It's crossing at 3. You just confirmed it. Okay. Determine the root. The root's the same thing. X equals 3. State the connection between the x-intercepts and the roots. The same. Okay, this is redundant again. We already did this. You're saying that you're finding the 0. You said equal to 0. Again, we get x equals 3. There. You can. Yep. Yeah. Yeah, so what is the other function? So you can say it's just x equals 3 is fine. But if you do write like this, Nolan, that's good too. Either's fine. And then it says, what's the connection between the zeros, the roots, and the x-intercepts? They're all the same. I already did a spoiler alert, so you guys realize that already. Same thing, I know. Sometimes this book's a little redundant. It's okay, they only do it one more time, and then we're going to get into some examples. All right. Investigation 2. So what's changing now is we're looking at a parabola. Okay, what's changing now is we're looking at a parabola, so now we're doing the quadratic piece. That last one was linear. We're not going to be doing those. Okay, this is what we're going to be focused on today. So we have Jock is determining the roots of equations x squared minus x minus 6. He wrote the equation in factored form and used the zero product law to determine the roots. Complete his work. So if I'm doing the zero product law, that was on your last test. It was x minus 3, x plus 2 for this one to be factored. So that means my answers are 3 and negative 2. Okay, so then for B, if we look at the graph, is that confirmed? Negative 2 and 3. State the connection between them. Same. Same. That's all I'm writing, yeah. Okay. Even, guys, if you want to even do this, we already did this right here. This is what the next part is, part D. So that goes to part D. I'll write it for you again, though. Just says consider the function, determine the zeros, right? So if you find the zeros. Okay. So say the connection between all three. And you guys get it's done. Same. They're all the same values. Okay. So, as I stated before, roots, x-intercepts, and the zeros are all the same value. Gosh, I think it hooks me. It's my bad. I got to stop stepping there. So, let's put it all together. Fill in the blanks of the following statement regarding the equation y equals f of x. Okay. So, the zeros of the function, the x-intercepts of the graph, and the roots of the corresponding equation are the same numbers. So all that's just confirmed. What's that? X-intercept, yeah, sorry, X-intercept. Okay, so we're just going to write these here of that graph we just looked at. We're just summarizing here. We've already talked about these, and we'll get some actual examples here. So this right here, x-intercepts we can see is 3 and negative 2. The y-intercept is negative 6, just for a bonus there. Function has the zeros of negative 2 and 3. Function has the roots of 3 and negative 2. They're all the same. All right. Okay, we'll slow down a little bit now because I feel like that was redundant. You guys are probably good with this one. So I'm going to go ahead and go to the calculator here so you can answer these questions on your own. But it says describe how the zero feature of the graph color can be used to determine the roots of the equation. So let's describe how you do that. So you take the equation. So step 1, put in y1 the equation. Step 2, graph. Step 3, second trace 0 is what you would do in order to find the zero of that function. Then just put a little note to yourself. need to do twice for 2 zeros. Okay, and we're going to do that part together here. So what I do in the graphing calculator, guys, you're going to fill these ones out on your own, okay? I'm going to go to my graphing calculator, okay, and you can sketch it. We're good? Yeah? Okay. So I'm going to come to mine here. 2x squared minus 7x plus 3. Okay, so hit graph. Okay. I got a good enough image. I can see my zeros. That's all that matters. Okay. So here we go. Second trace zeros. Okay. This is already left bound. So here's the 0. That's the left bound of it. So I'm going to hit enter. I'm going to hit the right trigger until I pass the 0. Passed it. Enter. Get close. Yeah, 0.5 or 1/2 is your first 0. Okay, so sketch us in the little grid there on this right side too. Not much of a sketcher. Okay, do the best you can. All right, 2. We're going to come over here. Okay, I'm on the left side. Hit enter. Click the right trigger until you pass it again. Enter. Get on it. Enter. 3. So 1/2 and 3 are your zeros. Okay. So I just showed you how to do that with the calculator. Now let's look at that same problem. Okay, so we did part B there. We just did this. And now we're going to do C where we're not using a graph calculator. So you do know how to do both. We're going to factor this. So back to unit 2. 2 times 3, 6. Factors of 6 that are -7, -1, -6. So we get 2x squared minus 6x minus 1x. I'll just make the run just so I can see it. Plus 3. I'm going to group. Take out 2x. Take out a -1. And fancy that. Look what our zeros kick out. 1/2 and 3. What we just got out the calculator. Full circle, yeah? So what are the zeros of the function? 1/2 and 3. All right, well, let's just take a breath for a second here. Any questions? It's a lot like lesson 5, right? Just using how to use the calculator now a little bit. All right. No questions then? All right. So, note, okay, find the zeros of function. To find the zeros of function of f of x, either substitute a 0 for f of x and find the roots, or graph the function and determine the x-intercepts. Those are your two options. Either set the function equal to 0, factor and solve, or put in your calculator and find the zeros by graphing. Okay, those are your two options. Now, if it says algebraically, what's that mean it wants to see? Steps of you factoring it. Okay, so on a quiz, if I say solve algebraically and you just put 2.2, that means you use your calculator clearly. You won't get full credit, right? So it's algebraically, just make sure you go ahead and factor that down. Okay? All right, cool. Here we go. Find the roots of the following equations. So if I want to find the roots of an equation, what do I want one side to be? 0. So we're going to go ahead and just say minus 33. Factors of 33 that are 8 apart. 11 and 3. So it's going to be x plus 11, x minus 3. You found the roots. The roots are -11 and 3. That's your answers. Why is that doing that? There we go. -11, 3 is what your x are, or your roots are. Yeah, that's a 3. This one? Or that's 3, yep. Sorry. Pen's kind of zigging out on me out there. Handwriting's bad, but it quits on me too sometimes. So what's cool about B? Don't need a factor. It's r set equals 0, and it's in factored form, so you just got to find the roots. Does a 6 affect anything? No, the 6 does not affect our zeros at all. It affects your stretch, but that's not what we're talking about today. So you know 3 is an answer, and negative 5 over 4. That's your answers. There you go. So, part C. What do we do now? What's your first step in the flowchart for factoring? Take out what you can. Now look at it. Aha. X squared minus 4. I like that a lot better, right? So x is plus or minus 2. You can write 2 and negative 2 separate. It's fine. Good? So remember, what we're doing is we're finding x-intercepts by making the y 0. How do you find y-intercepts? What do you make 0? The x, right? It's just a vice versa. So those are actually kind of easy to do, right? Because if I put 0 for these x's, what's the y-intercept? Negative 20. So let's just do that real quick. So the y-intercept here is negative 20. How about here? How about for B? What's the y-intercept? 10. And C? So I put a 0 here, everything's 0, right? Yep. So remember, to find the y-intercept, you just put 0 for x and you figure out what's left. Okay, that's all you have to do. What's that? Yeah, it's the constant usually, yes. Okay, so here we go. We're going to find the zeros this one. They all have a 5, so let's take a 5 out first before you start doing your decomp. I get x squared plus 3x minus 4. Now I want to factor that. So that's going to give me x plus 4, x minus 1. So your answer to that one, negative 4 and 1. B, we do have to decomp. I can't pull a 3 out or anything, so I do have to go 3 times 10 for 30. Factors of 30 that get you negative 11. Negative 6, negative 5, good. I know some of you guys are trying to write fast, I'll slow down here. Okay, so what just happened if you missed B? This is a decomposition problem. 3 times 10 is 30. Factors of 30 that get me negative 11 is negative 5 times negative 6. That's what we've done so far. What's that? Yeah, it's a negative 5x, yeah. Pull a 3x out. We get x minus 2. Pull a negative 5 out. X minus 2. So it's x minus 2 times 3x minus 5. So our zeros for that are 2. I'll just write it right here. 2 and 5/3. So I just wrote it right here. Okay. This one's nice. It's already factored. Okay, we don't have to do factoring. We just figure out what the zeros are. We get a 0 from this piece and that piece. So we have 2 zeros. So you see you have 2 x's. So what is the 2x in front? What's that 0? 0, yep. And the second one, negative 1/2. So 0 and negative 1/2, that one's already factored. All right, we're on the decline now. Let's got one more example. Good work. Okay, for each of the following functions, use graph calculator to sketch the graph of the function. Find the zeros as exact values. Write the function in factored form. Okay, so I'm going to kind of roughly sketch them. Or I'll kind of give you a little bit of hint here. I'll do the, when you do this one, you're going to get 3x plus 7 times x minus 1. So that means I'm going to have a 0 here, negative 7/3, so just past negative 2. Like that. And it's going to go like this. You can use your graph calculator, it's fine. Okay. And this one's a cubic, which we're not going to be doing a lot of factoring with those, but you guys could still handle it. Okay. You put in your calculator, you're going to see. So when you put in your calculator, what this tells you, let's see if you guys can do this part. This is a really good tool for Math 30. 7/4, so that's just below 2. Okay, so the graph goes like that. Like that. So what the graph is, I'm going to tell you the zeros. The zeros are negative 1, 1, and 7/4. So can you tell me what are the factors? Right? Well, there's 3 of them, because I have 3 zeros. So what are the factors? X minus 1, x plus 1. So he got that because there, right? Negative 1 plus 1, plus 1 minus 1. What's that? Say it again. X minus 7? 4x. Good. That's correct. 4x minus 7. Good work. So you got the 3 zeros. That's the factors of them. Okay. So if you FOILed those 3 out, what would you get? If you FOILed those 3 out and simplified all of it, what should you get? You should get that right there. You should get that right at the top. What's up? Okay. So the zeros, I told you guys this. I said the zeros are negative 1, 1, and 7/4. So what are the factors? Well, if negative 1's a 0, then x plus 1's a factor. If 1's a 0, then x minus 1's a factor. If 7/4's a factor, then add the 7, divide the 4, so 4x minus 7's a factor. And then these 3 multiplied get you the beginning if you did that. Does that make sense? Okay.